Assalamualaikum and salam sejahtera to Dr. Asida and everyone. Today we are going to present the implementation of memory allocation using the First Fit method. Before we begin, let me introduce our team members. So this is our team members. Firstly, we have Fakira Nudayana, next Aini Najwa, and myself, Irdina Shahira. Okay, now let's go through the table of contents. Okay, firstly, we have the concept of memory management, which is a crucial function of the operating system. Next, we have code logic and flow, which include first fit memory allocation, input, algorithm, and output. And lastly, we have a result and observation, which is the result of code and its observation. Okay, now, what is the concept of memory management? Memory management is a crucial function of the operating system that involves the allocation, management, and optimization. The goal is to manage operation between main memory and disk during process execution. It requires to allocate and deallocate memory before and after process execution. It also includes first fit, best fit, worst fit.
Shahira for presenting the previous part. Assalamualaikum. My name is Fakira Nudayana and I will be presenting the code logic and flow part. First, introduction. The objective of the Java code is to allocate memory blocks to processes using the first fit method. The input is array of memory blocks and process sizes, while the output is the code is able to produce allocation status for each process. For the second part of code logic and flow is the Java code. We use Microsoft Visual Studio Code as our tool to execute the program. We also choose Java as our programming language to execute this project. So this line is to display algorithm name, and this line is to define block sizes and also the process sizes. And line 12 and 13 is to get the number of processes and blocks. And line number 16 is to call first fit function to allocate the memory. And these values will be transferred into the first fit function. So this line is to declare an array to store allocated block for each process. -1 means not allocated. So this part is to initialize all processes as unallocated. And this part is to loop through each process to find suitable memory block. And this part is if the block size is sufficient for the process, then the process will allocate into the block. And this part is to mark the block as used by setting its size to -1. And break means to move to the next process to indicate first fit strategy. And this part is to display allocation results. As we run the code, we can know the status memory allocation. For process number 1, 250 will be allocated to block number 1, which is 350. The second process, 100, will be allocated to block number 3, 170. 300 will be allocated to block number 5, which is 500. And process number 4, 270, will be allocated to block number 4, 280, and process 280 will be not allocated to any block.
That's all for the explanation. I am Aini Najwa binti Adrus and will explain results and observation. As you can see at the top left, this is our result or output from our code that we have programmed, and there are 5 processes. And from the process, there is only one process that did not allocate it to the memory block, which is 280 KB. And why is that? So based on the output, we have do the visualization and also get the internal and external fragmentation for you all to understand the concept of first fit. So the first process is 250 KB. I fill it in 350 KB because it can fit the 250 KB. So when you minus it, there is still 100 KB that's still available. So the second process is 100 KB. I put it in this 170 KB, and when you minus it, there is still 70 KB that available. And the third process is 300. I fill it in 500 KB, and the balance is 200 KB. The fourth process is 270 KB. I fit it in 200 KB, 280 KB, and there is still 10 KB that available. And the last process, 280 KB, not allocated or unallocated because there is no memory block size that can fit the 280 process size. So when you want to find the internal fragmentation, you have to add all the available memory block size and you will get the total of available memory block size. I have attached the example, 100 KB plus 70 KB plus 10 KB plus 200 KB, and the total is 380 KB that are still available. As for the external fragmentation, is 50 KB because the process size that you can see here is all the process size is more than 100 KB. So the 50 KB for memory block size is external fragmentation. I think that's enough for our presentation today, and thank you for watching.